Hello, we're looking at problem number 3 on your, which is found on page 474 of your Geometry Part 2 textbook. This is using a theorem called the triangle angle bisector theorem, which is simply trying to say that if you have another line represented as PQ here that bisects one of the angles, then it creates segments that can be written proportionally. So in this case, RQ can be compared to QS. So this can be compared to this in the same way that PR can be compared to PS. And again, remember, this only works because you have a angle bisector here. So if I substitute the numbers in there, I can say that 10 is to 12 as 12 is to x. Okay. By cross multiplying, I end up with 10x equals 216. And all I'm doing here is simply cross multiplying there. That times that and that times that. Then you simply divide both sides by 10 here, and you end up with 21.6 as your answer. Okay. Now let's do the same thing again, just as a practice here for the got it section. I'm going to compare again 9.6 to 16 because that's my two bottom sections, in the same way that I'm going to compare y to 24. Now, is this the only way you can set it up? No, it is not, but it is the way the example gave us, and that's just what we're trying to follow. You could set the 9.6 to y and the 16 to the 24. You could do it that way and still end up with the correct answer. When you cross multiply here, this way and this way, you're going to get that 16y, and then 9.6 times 24 ends up being 230.4. If I then divide both sides by 16 here, I end up with y equals 14.4. So they don't all have to come out perfect. This is just an example of that, and of even actually the example 3 above didn't come out even either. So that's perfectly fine. But this is just showing you that you can only do this when the line that splits the big triangle into two smaller triangles is truly an angle bisector, which means it splits the angle perfectly in half. All right, hope this helps.